See, dear class 9 students, we are now introducing Euclid's geometry. The chapter is Introduction to Euclid's Geometry. So, Euclid was a famous mathematician. His contributions in geometry are wordless, speechless. So he wrote a book, the book name is Elements. In that book he wrote the definitions of various terms, but we are not taking all those definitions, only we are taking some of them. So these are most important. You will be asked in the examination, define point according to Euclid, define surface according to Euclid, like that. So according to Euclid, what is point? An exact location. It is an exact location. Point means, that means which has no part in it. It has no part in it. So it is point. What is line? Line is breadthless length. See how beautifully explained the definition of line. That has no breadth, but it has length. So it is breadthless length. It is line. How straight line is defined? That it lies evenly with the points on itself. A straight line lies with the points on itself, like so, like this. Straight line lies with the points on itself. Surface which has length and breadth, according to Euclid, it is surface. Plane surface, the surface which lies evenly with the straight lines on itself. Okay? So what is plane surface? The surface which lies evenly with the straight lines on itself. So say this is plane surface, which includes the straight lines, okay, and the surface together is plane surface. The next definition is solid. According to Euclid, solid is, it is a geometrical figure which has length, breadth and height. So solid has length, breadth and height. See, solid to surface, one dimension will be reduced. From surface to straight line or line, again one dimension will be reduced. From line to point, one dimension will be reduced. See, solid has length, breadth, height, 3 dimensions. Surface has only length and breadth, 2 dimensions. This is breadthless length, only 1 dimension. It has no part in it. So step by step you can see we are losing 1 dimension. Solid to surface, surface to line, line to point. It is most important point that you have to understand. Now, axioms and postulates. Axioms and postulates. See, both are meaning wise same, but where we do use see, the statements which required no proof, which are evidently true, which are universal truths. Are you following? The statements which required no proofs, which are evidently true, which are universal truths, are called axioms or postulates. Especially if it is a universal truth relating to geometry, the truth relating to geometry is called postulate. In all other areas, the universal truths are called axioms. Even in geometry also, you can call them as axioms. But in geometry, for axioms, there is specific name, that is postulate. So, axioms, postulates, this is relating to geometry, this word. These are universal truths. Which require no proof, which are evidently true. So now the interesting point is, what are axioms or postulates developed by Euclid, introduced by Euclid? This point is very important in mathematics. Dear students, Euclid's various axioms here we are learning interestingly. The Euclid's, the very first axiom is things which are equal to same things are equal to each other. It is most interesting and beautiful axiom. Things which are equal to same things are equal to each other. What does he mean by this axiom? Suppose say line segment AB is equal to line segment CD. The line segment AB is equal to the line segment CD. And suppose say the line segment PQ is equal to the line segment CD. So the length of line segment AB is equal to length of line segment CD. Length of line segment PQ also equal to length of line segment CD. So things which are equal to same thing. So these two are equal to same thing, then these two are equal to each other. Therefore, by Euclid's first axiom here, line segment AB will be equal to line segment PQ. Suppose if you take another example, say suppose x is equal to y and suppose say x is equal to z. Suppose this is example 2. So y and z both are equal to same thing which is equal to x. Therefore, according to Euclid's first axiom, y will be equal to z. Understood? So dear students, now Euclid's second axiom is if equals are added to equals, then the wholes are equal. See, for example, A equal to B. I am just showing you an example. Suppose say A equal to B. Now suppose if equal quantity P is added on both sides, then left side you get A plus P and right side you get B plus P. So A and B are equal and you are adding an equal value P on both sides. So LHS will become A plus P, RHS will become B plus P. So LHS is A plus P, RHS is B plus P. Okay, by Euclid's second axiom, the holes here A plus P and B plus P are also equal. So this is the thing which you have to realize in Euclid's second axiom. If equals are added to equals, then the holes are equal. See, these are equals. Okay, this equal to this, and the equal number P is added, okay, to equals, then the holes A plus P and B plus P, these are also equal. This is Euclid's second axiom. Dear students, now Euclid's third axiom is if equals are subtracted from equals, then the differences are equal. See, for example, A is equal to B. These are equals. Okay, now let us subtract P from both sides. Subtract P. Then LHS is A minus P. RHS is B minus P. So if equals are subtracted from equals, then the differences, what do you get? Those differences are equal according to Euclid's third axiom. Things which coincide each other are equal to each other. Are you following? See, I will give an example. Say, on a circle there is a point P and some neighboring point Q. Say, and Q is moving along the circle. Q is moving along the circle. So these are the various positions of the point Q. It is moving along the circle. These are the various positions of point Q. At some stage, that Q coincided with P. Then that Q will be equal to P. So things which coincide each other are equal to each other. So the point Q is equal to P. This is one way of explaining. So this is a good example. And another example, say there is a line A, this is a line segment AB, this is a line segment ACD, say for a moment. And now say that this point A is falling on C. So that A falls on C, then B falls on D, say. Then AB and CD coinciding. If A falls on C, B falls on D, AB and CD will coincide. So then AB will be equal to CD. So the things which coincide each other are equal to each other. Are you following? So these are two examples for fourth axiom. Dear students, Euclid's fifth axiom is the whole is greater than part. Whole is greater than part. So here I took the line segment AC whose length is Z units, and I took a point B in AC. On AC, I took a point B on AC such that part AB is equal to X. First part, this is the first part of line segment, part 1. The second part of the line segment BC is such that BC, this is the second part of the line segment, the part 2 of the line segment. This is BC, I took BC such that BC is equal to Y. So the line segment AC has two parts in it. One is AB and another is BC. AB is of length X, BC of length Y. So obviously our Z, whole is our Z, is equal to X plus Y, sum of the parts. Whole is the sum of the parts. So Z is equal to X plus Y. Obviously this Z will be, okay, more than each part X. and y. Obviously z will be more than x because it is a whole. Whole is greater than part. So z is greater than x and z is greater than y. This is what we mean by the whole is greater than part. This is Euclid's fifth axiom. Dear students, Euclid's sixth axiom is things which are double of the same things are equal to each other. Suppose say the thing x is double of y, and say our another thing z is double of y. So x and z are double of same thing. Then you, according to Euclid's sixth axiom, x is equal to z. Did you understand? So similarly we can explain the seventh axiom. The seventh axiom is things which are halves of the same thing. Things which are halves of the same things are equal to each other. Same example if you take, suppose x is half of y and say z is also half of y. Then according to Euclid's axioms, x would be equal to z. So these are the 7 Euclid's axioms, okay, which are available in Euclid's geometry.